In this video, we're going to determine whether a linear binomial is a factor of a polynomial by using either direct substitution or synthetic division. So in order to begin talking about if a binomial is a factor of a polynomial, we have to talk about the factor theorem. And the formal definition of the factor theorem states that a polynomial represented by f of x here, just to keep it general, a polynomial has a factor x minus k if and only if f of k equals 0. Now what this is saying in really fancy math terms is it's saying you're going to take your k value here, which we've talked about. If we had something like x plus 2, we know k is the opposite, so k would become negative 2. So regardless of our situation, we determine our k value, and then what we do is we take our k value, whatever it is, and we substitute it in place of x in the function. So if k was equal to a negative 2, we would replace every x with negative 2. And what should happen if that binomial is in fact a factor is that the result when you replace x with that k value is the entire function will result in a value of 0. So what we're really finding here when we replace our x value with our k value and it equals 0 is when we find factors, we're also finding if k is an x-intercept, or what's called a 0 of that function. So let's apply this thinking to the example down below. So I have two examples here. One of the examples says is x minus 2 a factor, and the other example says is x plus 5 a factor. So we're going to do both of these and see what happens in the different situations and determine if either one of these is a factor of this polynomial function here. So we're going to do x minus 2 first, so let's start with that one. And remember in here, to determine if this is a factor, we need to start by finding our k value. And our k value is the opposite of that numerical value, or it's whatever x needs to be in order to make x minus 2 equal 0. So in this case, k is equal to 2. So what we're going to do here is we're going to replace every single x value in this function over here with 2. And if this is in fact a factor, what's going to happen is that whole function is going to result in it equaling 0. So I'm just going to give myself a little more space here. So k is equal to 2. So if we take this function, so we take f of k, which in this case is 2. We take 3 times 2 to the 4th plus 15 times 2 to the 3rd minus 2 squared plus 25. So 3 times 2 to the 4th becomes 3 times 16, plus 15 times 2 to the 3rd is 8, minus 2 squared is 4, plus 25. So 3 times 16 is 48, plus 15 times 8 is 120, minus 4, plus 25. Then if we add these together, 48 plus 120 is 168, minus the 4 is 164, plus 25 is 189. So we can see here this is not resulting in 0. So what we can state for a fact based on the work that we have here is that x minus 2 is not a factor, because if it were a factor, this would result in 0 when we replace x with our k value. So now let's go through this same process with the second example here of x plus 5. Remember, to determine our k value, it's really the x value that makes x plus 5 equal 0, which in this case makes our k value equal to negative 5. So what we're trying to determine here is whether or not this will be a factor by taking k is equal to negative 5 and replacing every x value with a negative 5. So here if we take f of negative 5, we have 3 times negative 5 to the power of 4, plus 15 times negative 5 to the power of 3, minus negative 5 squared, plus 25. So here this becomes 3 times Negative 5 to the power of 4 is 625, plus 15 times negative 5 to the power of 3 is negative 125. Then we have minus, well, negative 5 squared is 25, plus 25. So then if we multiply 3 times 625, we get 1875, plus 15 times a negative 125 is a minus 1875, minus 25 plus 25. So if I start adding these together, I can see 1875 plus a negative 1875 becomes 0. Then if I subtract 25 from that, it's a negative 25. And if I add 25 to that, that goes back to 0. So when I go through this process and I substitute my x value with my k value here, what I discover is that the whole function results in 0, which is telling me that x plus 5 is a factor and is telling me that this k value of negative 5 is in fact an x-intercept for this particular polynomial function. So we can use substitution really easily using our k value to check and see if we have a factor or not. So while the substitution method is great, you can see that sometimes we get some really large numbers. So it's really easy to make a mistake if you're not careful with your symbols. But what's really nice is that we have a second option here. So while we can always utilize the substitution method, what we can also do is we can utilize synthetic division to determine if a binomial is a factor as well. And we can do so because a polynomial, f of x, so again notice in general, has a factor of x minus k if f of x divided by x minus k. So this is division here. And if we divide that polynomial by our factor and it results in a remainder of 0, it means that it's a perfect factor and that it does in fact go in evenly, and we have again an x-intercept or a 0 at our k value. So we're going to go through the same process with the same two sets of numbers, but this time we're going to utilize synthetic division instead. So let's look at the first example here. So again, we have x minus 2 as our factor, and we know that our k value is equal to 2. So if we set this up using synthetic division, I know that my 2 is going to be the number on the outside. And then my numbers inside here, we have 3x to the 4th, 15x to the 3rd, negative 1x squared. I need to add a plus 0x in there, and then I have 25 as my constant. So I'm going to use synthetic division here to figure out if x minus 2 is in fact a factor. And if it is a factor, it will have a remainder of 0 at the end. So remember, with synthetic division, we bring down the 3 to start. 3 times 2 is 6, so we put that here, and then we add straight down. So if we add straight down here, we get 21. 2 times 21 is 42, so we put that here. Add straight down, so we get 41. 41 times 2 is 82. Add straight down, we get 82. 2 times 82 is 164. Add straight down, and we get 189. So we can see here that we have a remainder of 189. So what this is telling me is that x minus 2 is not a factor, which is consistent with what we saw on the previous page. So now if we repeat this process with the second example here, we can do x plus 5. And so we set this up in the same way. Remember, k is equal to negative 5. And so here we would have 3, 15, negative 1, 0, and 25 again. So we go through this exact same process here. We bring down the 3 to start. 3 times negative 5 is negative 15. Add those together and you get 0. 0 times negative 5 is 0. Add straight down, that's negative 1. Negative 1 times negative 5 is 5. add straight down, so we have 5, and 5 times negative 5 here is negative 25. Add straight down, and we find our remainder here is 0. And because our remainder here is 0, this is telling us that x plus 5 is a factor. So as you can see, synthetic division works really slick for checking if one of those binomials that you have is in fact a factor. So I prefer synthetic division as it's a little bit cleaner and I'm less likely to make a mistake. But if you like substitution, you can obviously use that strategy as well. So on this slide here, I just want to point out another way that this question may be worded that's a little bit different than what we saw in the past few slides. So on the past few slides, we saw asking is x minus 2 or x plus 5 a factor? And you'll notice this one is asking is x minus 3 a 0? Asking if x minus 3 is a 0 is the same thing as asking if x plus 3 is a factor. So here in this case, they are just telling you in the instructions k is equal to negative 3, and they're saying negative 3 is a 0, which a 0 is a fancy way of saying is an x-intercept value. So note that this is asking you to do the exact same thing, it's just wording it in a slightly different way. So don't let the wording confuse you. Just know that if they write it in this way and ask if negative 3 is a 0, they are just outright giving you the k value, where if they are asking, if x plus 3 is a factor, you have to then apply that and find that your k value is negative 3. So let's go through this process one more time to check. I'm going to use synthetic division here as I think synthetic division is a little bit cleaner and a little bit easier to use. So I know that my k value is negative 3. I then know that my polynomial here has the first coefficient of 2, second one is 10, negative 11, negative 1, and 6. And what I notice here is that I'm not missing any terms, so I don't have to add in any zeros. So I'm going to use synthetic division here, and if this is in fact a 0 of that function, the remainder needs to be 0 at the end. So we start by dropping the 2. 2 times negative 3 is negative 6. Add those together straight down, we get 4. 4 times negative 3 is negative 12. Add those straight down, we have negative 23. Negative 3 times negative 23 is 69. Add those straight down, we have negative 68. Negative 3 times negative 68 is 204. Add those straight down, and we find that we have a remainder of 210. So what we can confirm here is that negative 3 is not a 0 because we found a remainder here when synthetic division was used.